design second problem in design of tension member. So design a tie member to carry an axial load. Okay, 400 kilonewton is working load. Use double angles with M20 HSFG bolts, property class 10.9. Okay, suppose if you are going to solve design problem, there are minimum three requirements. One is the given values are force, types of section, whether it is bolted connection or welded connections, then type of section, right? So next is connection. Type of connection is whether it is bolted connection or welded connections. So in that, first step is whatever the load is given, working load is 400 kilonewton. Okay, first we need to do ultimate load. Okay, to calculate ultimate load, 1.5 factor of safety is multiplied with the working load, then you will get ultimate load of 600 kilonewton. Okay, first step is calculate working load to the ultimate load. After calculating ultimate load, so first step in specifications for design, so area required. Okay, area required is gross area AG. Gross area is AG. So here to calculate AG value, one is ultimate load into gamma m naught divided by F5. Okay, this is the equation. So ultimate load is 600 into 10 power 3 into factor of safety is 1.1 dividing by always F5 value is 250. Then you will get 2640 mm square. Then this value is in terms of centimeter square, 26.4 centimeter square. Now always increase the approximately 30% of the area. Okay, so actual area is 26.4 into 1.3, then you will get 34.32 centimeter square. Okay, increased area. Now using steel table, trial the section. Okay, for double angle section is already mentioned in problem. So 2 ISA 80 into 80 into 12 mm. So okay, always what we are going to choose trial section is more than the actual area. Okay, so actual area is 34.32, but here from trial section 35.62 centimeter square. Okay, the first step is calculate the trial the section and area. Okay, now write down the figure for double angle section. It is also given in steel book only. Okay, so whatever the figure is given in steel book, we should write the same figure. First step is we need to calculate the area and select the suitable section. Okay, so after selecting the suitable section, next step is section. Okay, whether it is bolted connection, type of connection or welded connections. Okay, for bolted connections, if it is double angle section, no slip joint. Okay, there is no slip between the member. Okay, or connection. So that's why you have to write in no slip connection. Now given property class is M20 HSFG, both property classes 10.9. Okay, the equations of, suppose if you are going to calculate strength of the bolt, page number 76, all the equations are given in IS 800 2007. First note down slip factor, mu equal to 0.55. NE, if it is single angle section, NE value is 1. Okay, number of connections. If it is double angle section, take number of interfaces 2. Then KH equal to 1, always it is constant. Okay, KH equal to 1 or is always constant 1. It is also available in equation 1. Now to calculate proof load, F naught equal to proof load. So to calculate F naught, always consider the shear plane within the thread is within the plane. Okay, so now for this we need to calculate NN equal to 1, A and B equal to 0.7 into FCK, 0.7 into pi d square by 4. Okay, so now the equation for proof load equal to A and B into 0.7 into FUB. Okay, first calculate A and B value. NN equal to 1, A and B equal to 0.7 into pi by 4. D is diameter of the bolt is 20 square. Now you will get 245.04 mm square. Area of the only threaded portion. There is no shank part. Okay, just you have to consider only threaded part of the bolt. Okay. Now FUB. So FUB is, we can also choose strength of the bolt. Okay. So ultimate shear strength of the bolt is always you can take, it is based on property class. If the property class is 10.9, then it is 1000 Newton per mm square. FUB. Now substitute A and B and F naught in F naught equation, then you will get F naught equal to 245.04 into 0.7 into 1000, then you will get 171.53 10 power 3 Newton. Okay. First we need to calculate the proof load. After calculating proof load, next step is, now we need to design nominal shear capacity of the bolt. To calculate nominal shear capacity, so as I already told, the equation is available in page number 96 IS 800 2007. VNF equal to mu F slip factor into NE constant, KH is also constant, then F naught. Okay, proof load. Now substitute all the values, then you will get VNSF equal to 188.68 kilonewton. After calculating VNF value, next is design value. Okay, our design strength of the bolt, our design bolt value equal to VDF equal to VNSF by gamma MF. Gamma MS is factor of safety. Always you should take 1.25. It's a factor of safety, constant value. Okay. Now VDSF equal to 188.68 is the VNSF value. Dividing by 1.25, you will get 150.94 kilonewton is the VDSF value. Okay. After calculating VDSF value, now we need to calculate number of, for connections, number of bolts required, right? So to calculate number of bolts equal to force. Okay, factored load is how much? 600 Newton. Dividing by strength of the bolt is 150.94. Then you will get approximately, you will get 4 number of connections, 4 number of bolts. Okay. Now we should draw the figure. So double angle section is already written in figure. Okay, using steel table. Now the connection will be, we need to calculate pitch and edge distance. Pitch equal to 2.7 into D naught, E equal to 1.7 into D. Okay. So D is diameter of the bolt is 18 is given. Okay, 20 is given. Then clearance you can take for up to 20 mm 2. Okay, 22 is D naught. Then you will get pitch is 50 mm, edge is 40 mm. Now again in steel table only, note down the value of LT and C value. Okay, C is the central distance. Okay, LT value is also directly you will get from LC these equations. Okay. Now after note down this value, W is 80 mm, C W1 equal to 40 mm, then thickness of the member equal to 12 mm. Okay. Now second part is connection over. Next is, third step is check for the shear strength. Okay, or check for the strength of the connection. That is very important. Okay. Now here mainly there are three categories. We need to satisfy the, always this value is more than the actual load. Okay. So what we are already calculating, 1.5 into 400, you will get 600 Newton, right? So the whatever the value you are getting from three equations, the value is more than actual factored load. Okay. So yield strength equation is TDG equal to AJ, gross area. Okay. For trial section, gross area is 35.6. You are getting from three equations, the value is more than actual factored load. Okay. So yield strength equation is TDG equal to AJ, gross area. Okay. For trial section, gross area is 35.62 centimeters square, right? Into FO is 250 divided by gamma M naught. And the value is 809.5 kilonewton is greater than 600 kilonewton actual load. Then only it is safe. Otherwise, we need to revise the section. Okay, what we are already chosen in trial section, we can change the trial section again. We need to increase width and width of the connection. Okay, now it is okay, safe. Next is for rupture strength. So this is beta equation is also available in page number 76. Okay, so now note down the equation is beta equal to 1.4 minus 0.076 is constant, B by T, Fy by FUB, W plus W1 minus T by W, B value. Okay. So here beta values in between always take 0.7, so greater than 0.7 and less than 1.44. Okay. Substitute all the values. You already know the value of B is 80 mm. When we are choosing trial section, B value is 80 mm. T is 12 mm, FOL is 250, FUB is 410, then W is 80, W1 is 45, T is 12. Substitute all the values, then you will get beta value is 1.17. This value is in between 0.7 and 144, then it is okay. Now we need to calculate the AGO value. AGO is strength of area of the gross area of the connection, bolt value, B minus T by 2 into T. This equation also available in code book only, no need to worry. Okay. Now B is 80, T is 12, then again T by 2, 12 by 2 into 12, then you will get 888 mm square AGO value. Similarly, A and C connection, area of the connection is A, area over B. Okay, A or B minus D naught minus D by 2 into T. Now A is equal to B value 80 minus D naught. It's I already mentioned. So always take D naught is diameter of the hole. Diameter of the hole plus clearance is 2 mm. So total 22 mm minus T by 2 is 12 by 2 into 12 is 624 mm square. Okay. After calculating these two values, okay, TDN. First is TDG, second one is TDN. So now the equation is 0.9 into ANC into FU dividing by gamma MU plus 1.17. 1.77 is beta into AGO into B by gamma M naught. So here if it is double Lagrange section, multiplied all the values is multiplied by 2. Okay. So now you will get TDN value equal to 840.6 kilonewton. Then this value is also greater than 600 kilonewton, then it is safe. Okay. So now the last step is, okay, two conditions are satisfied. Okay. So then last step is block shear strength. That is very important. Okay. So to strength or to check the diameter of the hole after including clearance. Okay, that is very important. Usually block shear strength is occurs at the bolt hole. Okay. To satisfy this, first we need to calculate the LV value. Okay. LV value is, okay, first is edge distance till the last connection. Okay. How many pitches are there? 3 pitches plus 1 edge distance, LV. Okay. So 40 plus 3 into 50 equal to 190. LT is, okay, B minus 45, C value in vertical distance. Always take LT in vertical direction, LV is in horizontal directions. Okay. So LT value is 80 minus 45, 35 mm. Now calculate AVG equal to LV into T. LV is 190 into 12, 2280 mm square. AVN equal to 2280 minus 3.5 into 22 into 12, 1356 mm square. After calculating these two values, we need to calculate the area of the thickness of the plate. Okay. So LT into T. LT value is 35 into T is 12. So 35 into 12 is 420 mm. Then gross area ATN for connection 420 minus 0.5 into 22 into 12. Then you will get 288 mm square. After calculating these values, now substitute in equation TDG, TDB value. Okay. So then you will get 768.38 kilonewton is also less than 600 kilonewton. Okay. TDB value is 653.12 kilonewton is greater than, again less than, greater than 600 kilonewton. Okay. So all three equations are satisfied. Okay. All the values are more than the actual factor load. Okay. 600 Newton. Hence, provide 2 ISK 80 into 80 into 12 mm with 4 bolts M20 of HSFG property class 10.9. Okay. So try to solve this problem and also try to go through the question papers. Okay. At least so tell for Monday you have to submit 2 question paper problems. Okay. Okay. With this I will end up the class. Thank you.